Welcome, folks! I've nearly finished setting up my new location. I will get my Rust logo hung back up for the next video. Speaking of Rust, Rust 1.77.0 was released on March 21st, 2024, thanks to the hard work of hundreds of contributors. First off, let's go over the highlights that were covered in the Rust blog. Number 1. Rust now supports C-string literals. This is super awesome for anyone who needs to deal with FFI and C-style strings. In your source code, this style of string literal looks like a regular string, except that it has a little C character in front of the string, which makes it a C-style string terminated with a null byte, instead of a Rust-style string with modern amenities. The type of a C-style string literal is a static immutable reference to a C-str, but it's faster than making one at runtime because the compiler will do the validity checks at compile time. For instance, making sure there are no null bytes in the interior of the string. Number 2. Async functions can now be called recursively. In earlier versions of Rust, this was impossible because the compiler stored coroutine witness types directly inside of the coroutine, and the coroutine could not contain itself as a witness field without creating a cycle in the type representation of the coroutine. If that sounds interesting to you, there's a link in the description for you to get more details on that. Now the implementation has changed, so recursive async function calls are now possible to implement, and that implementation has been done. Calling an async function recursively looks like this, mostly like you would expect, but there is one practical limitation to point out. To call an async function recursively, you do need to add some indirection to it, like these box pin calls. Otherwise, the state of the async function would have an infinite size, and currently, computers do not have an infinite amount of RAM. I'm curious though, outside of college course assignments, I have never encountered a case where recursion was clearly a better solution than iteration in an imperative language. Can someone enlighten me as to why anyone would actually want or need to do this in Rust? If so, tell me in a comment below. Number 3. The offset of macro has been stabilized. This macro provides the byte offset of a public field of a struct without needing an existing instance of that type, which is super useful. To use it, you pass in the name of the struct and the name of the field, and the macro expands to a usize value representing the offset you're looking for at compile time. On my box, this code printed the number 16. Number 4, the precompiled standard library that ships with Rustdoc installed versions of Rust has debuginfo included in it. This means that release builds and other profiles that don't include debuginfo in your compiled code still get debuginfo in the standard library portions that are statically linked in. Until now, anyway. Now if your code doesn't include debuginfo, then the debuginfo from the standard library is stripped out of your build. I tested this out myself on macOS on a trivial project compiled in release mode and found that the space savings were significant, but at least on macOS I found that running strip on the binaries produced a still smaller version. So either strip is doing more than just stripping debuginfo from the standard library portion of the binary, or macOS is special. I'm curious to know what is going on here. Please comment below if you can help clue me in on this. In any case, things are definitely going in the right direction. However, after Rust 1.77.0 was released, it was discovered that this was not working as intended on Windows with the MSVC compiler. So Rust 1.77.1 was released on March 28, 2024 as a hotfix to disable this functionality in that environment. I expect this will be re-enabled in a future release. Number 5. Before I get into this one, I need to give you a warning. My friend Ed Page let me know that despite being in the blog post initially, although it's now been removed, and despite being listed as available in 1.77 on Clippy's website, this lint will not actually be available until Rust 1.78, which is coming out in May. See the links in the description for more details about the early publishing. I'll cover it anyway, just for funsies. The warn by default incompatible MSRV lint will be a new warn by default lint. MSRV stands for minimum supported Rust version. The Rust project itself only officially supports the latest stable version of Rust, but others can choose to support any number of older versions of Rust if they want to. You can make this support known in a variety of ways, one of which is by specifying the Rust version package setting in your Cargo.toml. This new lint, once it actually comes out, will warn you if you use features from any version of Rust newer than the minimum supported version that you choose. That covers the changes highlighted in the blog, with the exception of the stabilized APIs, which we'll cover later on in their own section. Let's go over the other Rust language changes that didn't hit the front page news. Number 6. There is now a clear policy about how to deal with exhaustiveness of opaque types when pattern matching. The policy revolves around using the concrete hidden type inferred within the body of an item that defines it. For more details on that, see the link in the description. The benefit of this change is that pattern matching works a little bit better, and a situation that could cause the compiler to crash was eliminated. Number 7. The new unsafety checker has been stabilized. The unsafety checker is part of the compiler internals. It now uses THIR, or typed high-level intermediate representation, instead of mir, or mid-level intermediate representation, to do its thing. This feature has been in the works since 2021. I looked for any description of what the effect of this change would be, and all I found was performance tests that showed it was significantly faster. So there you go. Number 8. There is a new static mute refs compiler lint that is worn by default in the 2021 edition of Rust, but will become a hard error in the 2024 edition of Rust that should come out later this year. This lint looks in unsafe blocks for any type of reference to a static mutable variable and lets you know that's going to lead to trouble. Number 9. The unstable features compiler lint was undeprecated just so it could be used inside the compiler itself, so that compiler developers don't accidentally use unstable features in parts of the compiler that must be compiled with the stable compiler. Number 10. The co-inductive overlap incoherence lint that was warned by default in Rust 1.73 and then deny by default in Rust 1.75 is now a hard error that you can't disable in Rust 1.77. They must be feeling pretty confident with this one. Number 11. In yet another compiler internals change, the const-eval interner has been completely replaced with a new implementation. The const interner is the code that takes the final result of a constant evaluation from the local memory to the global memory it needs to be in. The new implementation better detects mutable references that try to sneak into the final value. For now, it polices this situation by triggering the future incompatibility lint, but in the future it should become a hard error. Number 12. Braced macro invocations are not allowed in let-else statements. Macro invocations usually look a lot like function calls using parentheses, but you can optionally use square brackets or even curly braces instead of the parentheses in most places for the same effect. This makes it so you can use whichever of the three seems to make most sense stylistically. If the macro is like a function call, then use parentheses. If the macro is more like initializing a vector, then use square brackets. You get the point. Well, a let-else statement is one place you cannot use the curly braces. One reason is that the presence of a curly brace before an else is supposed to indicate that it is part of an if expression, not a let-else statement. The other reasons deal with similar ways of eliminating ambiguities. Number 13. The soft unstable lint will now show up in future breakage reports. This lint detects using bench attributes, custom inner attributes, and inner macro attributes. Number 14. Because of an LLVM bug that had to be worked around, 128-bit integers have been 4-byte aligned in Rust, which makes them incompatible with C and with Rust compiled via GCC. The upstream LLVM bug has been fixed, so the alignment is now correctly set to 16 bytes. There is an entire long-format blog post about this topic that goes into far more details and also explains some things that won't take effect until 1.78 is released in May. If you are interested in more details, check out the link in the description below. Number 15. Rust's compiler diagnostics were ignoring the --verbose compiler flag, which seemed kinda silly. Now when the --verbose flag is present, diagnostics print out more information, like showing full types and error messages and not eliding similar types. Number 16. The compiler now makes better use, or non-use as the case may be, of spaces around tokens like semicolons and other punctuation. Number 17. The unused tuple struct fields compiler lint has been merged into the dead code compiler lint because unused code is dead code. The dead code lint is now warned by default instead of allow by default. Number 18. When there are incorrect implied bounds in the well-formedness check, an error is now omitted. This is super vague, and I couldn't find a great way to explain it, so there's a link in the description below if you want more details. It is interesting to note that there is a hard-coded exception for this error for the popular Bevy game engine, since it would break folks using Bevy at the moment. This exception is slated to be removed once Bevy is no longer affected by it. But how awesome is it that folks are willing to hard-code exceptions like this for the sake of the community? Very awesome. Number 19. The compiler typically emits column numbers in terms of Unicode code points, which are variable numbers of bytes for characters outside the ASCII range. However, the coverage reports that the compiler emits are fed into the LLVM-cov tool, which expects columns in terms of single bytes, not Unicode code points, which means it would break whenever it dealt with non-ASCII text. This has been fixed. Number 20. This PR bundled 3 distinct changes. First, all function item arguments are now checked for well-formedness. Second, the borrow checker uses implied bounds to accept more code and mitigate the impact of the first and third changes that I'm talking about. And third, user type annotations are now checked for well-formedness before normalizing them. For more information, see the link in the description below. Number 21. 2 targets have been promoted. These 2 bare metal RISC-V processor targets have been promoted to Tier 2. Congratulations! If you know what devices this would actually affect, fill me in the comments below. Number 22. There are 4 new Tier 3 targets. Let's go over them. First up, we've got Illumos, a derivative of OpenSolaris on ARM64 processors. Then we've got a bare metal target for the 32-bit Hexagon DSP chips, like the Hexagon V73, and then we've got a target for the Espressif Internet of Things development framework on 32-bit RISC-V processors, and finally a target for RISC-Zero's zero-knowledge virtual machine running on 32-bit RISC-V processors. Number 23. You can now convert a reference to a fixed-sized array into a copy on write of that array. You could already make this conversion from a vector or a slice. This just adds the ability to convert from a fixed-sized array reference without first casting it to a slice. Number 24. The vex split-off method had special handling when passed 0 as an argument that caused it to steal the old vector's buffer with its existing contents to avoid a copy, and then allocate an empty buffer of the same capacity to put back in its place. However, it was decided that this resulted in the surprising behavior that the returned vector's capacity was no longer determined by the current size of its contents, as would be expected for a freshly allocated vector. So, this special case was removed. Now let's go over the APIs in Rust that stabilized in 1.77. We've already covered the mem offset of stabilization in number 3 above today, so we'll skip that one. Number 25. 2 array primitive methods have stabilized, each ref and each mute, which return new arrays containing immutable or mutable references respectively to the values in the original array. These are particularly useful when combined with the map method. Number 26. The core net module has stabilized. This moves the networking primitives related to IP addresses from the standard library to the core library. Of course, they're still re-exported in the standard library in the same place, so code using the standard library won't have to change. But now they're also available in core for non-standard library usage. This includes the IP address types, the socket types, the enum for indicating the multicast scope, and the address parsing error struct. Number 27. The round ties even method for floating point types has been stabilized. This method rounds the float to the nearest integer, rounding halfway cases to the number with an even least significant bit, using the LLVM round-even intrinsic. With the stabilization of this method, Rust now exposes all 5 IEEE 754 rounding modes. Who knew rounding was so complicated? Number 28. A whole bunch of slice methods dealing with chunks have been stabilized. Let's go over them. We've got a good number of them to look at. First, let's clarify that when we say chunk, we're talking about a slice of something instead of individual items. The chunk by methods take a predicate to to determine what items are separators, and then returns a non-overlapping iterator that returns each chunk separated by the separator. All of the methods on this page come in pairs, where one uses immutable references and the other uses mutable references, so I won't bother pointing that out again for the rest of them. The first chunk methods take some size n as a const generic parameter via the turbofish, and return the first n items from the slice as a chunk, either immutably or mutably, respectively. All of the subsequent methods on this page also take this sort of const generic parameter. The split first chunk methods are similar, but also return a slice to all the remaining items in the original slice. The last chunk methods are also similar to the first chunk methods, only they return a slice to the last chunk instead of the first chunk. And finally, the split last chunk methods are just like the last chunk methods, but also return a slice to all the items in the original slice before the last chunk. Number 29. The map method of the bound enum was stabilized. Bound is an enum in the standard library used by ranges, which has two variants that are generic over the same type. The new map method lets you apply a function to the wrapped value, replacing it with a different value, potentially of another type, but preserving the enum variant. In other words, you can use map to transform from included t to included u, or from excluded t to excluded u, and of course, for the unbounded variant, the map call is a no-op. Number 30. File create new was stabilized. There's already a create method for the file struct, but that method will open the file if it happens to already exist. If you want to guarantee that you create a new file, up until now you had to do file, options, read true, write true, create new, true, open, and then pass in your file name. That's kind of a mouthful. So now we can just do file, create new, which is a much nicer alternative. This is the first contribution I have covered from Josh Triplett since he gave me permission to use his name and picture for contribution callouts. Thanks, Josh! Number 31. Both Mutex and RwLock have stabilized a clear poison method which clears the poison status. Poisoning occurs when a thread that holds a Mutex or RwLock panics. Until now, there wasn't a way to clear the poison status, which means if poisoning occurred, you either had to replace the Mutex or use awkward workarounds like this to get access to the poisoned value. And this isn't any fun at all. Of course, you better either overwrite the value or verify that it is a valid value before clearing the poison. Otherwise, you're just getting easy access to a poisoned value. Next up, we have a smattering of Rustdoc documentation site changes. Number 32. Links are now allowed in markdown headers in documentation. That's pretty self-explanatory. Number 33. In the documentation search box, more of the parens-based type expression syntax is now supported. Specifically, you can now use empty parens to search for both the unit type and for tuples, parens around a type to just search for that type, and parens with a type and a comma searching for tuples containing that type. Number 34. There's a new icon for the button to expand the files pane in the doc's source code view. Here is before, and here's after. The new button icon will hopefully make it more obvious that the pane can be expanded to browse through the source code of the other files, which I never noticed, so good thing they're making it more noticeable. Number 35. The settings page of the docs was grabbing the theme settings stored in the browser's local storage and expanding it unchecked into the page source, which could be problematic if the values in local storage were monkeyed with. The settings page now sanitizes the value it retrieves to avoid this problem. Number 36. The Rust style guide now recommends using version sorting style when doing things like ordering your imports in use statements or listing keys in Cargo.toml. This probably won't affect many people directly, but it's great to have defined so that automated tools sort things consistently. This is another contribution by Josh Triplett. Thanks, Josh! Number 37. Did you know there is a file in Rust that simply contains expressions that look really weird but are valid? This is because these weird expressions are not expected to ever be encountered in the wild, but they're valid Rust code and we want to make sure they continue functioning as expected, plus it's fun to collect weird things. I consider this kind of like documentation, which is why it's in this section. There are two new weird expressions. First, we have this crazy looking loop with return, break, and what looks like a bunch of trash. As far as I can tell from my testing, these exclamation marks are the unary negation operator, but never get to be evaluated. Since there's no semicolon at the end of this line, the expression continues on to the break statement in the next line, which is evaluated before the return. So the number 1111 is bitwise negated 6 times, which ends up canceling itself out and evaluating to 1111 again, and then is returned as the breakout value of the loop, which becomes the tail expression for the function, so the function returns 1111. The return and its exclamation marks are ignored since the break is evaluated first. Cargo format will move the break onto the same line as the return, which helps mentally parse this better. However, the compiler, paradoxically, emits a warning, and Rust Analyzer will repeat this warning, stating that the break statement is unreachable because it's after a return. But that's not actually true because the return's expression is evaluated before the return itself, and the break is in that expression. At least that's the behavior I see when I compile and run the code. Now, maybe I'm not understanding what's going on correctly, so if John Jensen or some other Super Rust compiler internals guru has more info, please fill me in. The second weird expression today is easier to understand. Note that Rust format is disabled for this entire file of weird expressions, otherwise a lot of these expressions wouldn't be able to look so weird. In this one, the white space has been tweaked to make it look like a bunch of control flow statements are actually macros. The compiler isn't fooled and Rust Analyzer isn't fooled. As you can see by the syntax highlighting here, my color scheme makes macros green and italicized, and these are red. And if you run the code through Rust format, then it fixes everything up to look more normal. It's really just negating a bunch of values that are evaluated from inside braces or parens. Now let's go through a bunch of cargo-related changes. Number 38. Build scripts can emit output which configure cargo to act in specific ways at build time. The old cargo prefix with a single colon had limited functionality, and a new cargo prefix with double colons has been added to unlock the path to adding new functionality without breaking the old way of doing things. If you omit this sort of thing from a build script, there's a link in the description below where you can get more details. Number 39. Various cargo subcommands deal with packages, but there wasn't an unambiguous way to map the ID field returned by the cargo metadata command into an ID usable by the other cargo subcommands. Now these commands all use an unambiguous package ID spec format, which makes mapping the package from one command to another unambiguous. Thanks, Ed. Number 40. The deserialization schemas for cargo have been pulled out of cargo proper and into a separate crate named cargo-util-schemas. This is the code responsible for parsing cargo.toml and makes it possible for other projects, like crates.io, to parse things exactly the same way cargo does. Thanks once again, Ed. Number 41. The job server, or the part of the build system that enables building things in parallel, is now inherited from the environment for all runner kinds. So, for example, if you need to do a cargo run from a makefile of some external project, that can now inherit the job server. In other words, Rust can compile faster now when you mix it into external build scripts. Number 42. Plugin support has already been entirely removed from the latest Rust C compiler versions, and the corresponding plugin support has now been deprecated in Cargo. Plugin support will be entirely removed from Cargo in a future release. Number 43. The -c help cargo flag now produces colored output that looks like this. Your specific colors will be determined by your terminal settings, of course. Number 44. Cargo is beginning to style errors more like Rust compiler errors are styled. The first error whose style has been updated is an error encountered when parsing cargo.toml. Number 45. The cargo vendor subcommand now holds the mutate exclusive lock to block any other cargo processes that may want to read or change the vendored files while cargo vendor is playing with them. Number 46. Cargo now only sets the content type header to application JSON when sending a GET request with a body, like it is supposed to do. I'm sure crates.io will be very pleased about this newfound conformance to proper protocol. Number 47. The outdir environment variable was not being set in a few corner cases. Now it is always set for units with build scripts like it is supposed to be. Number 48. Cargo add would occasionally select the wrong package to add if you specified a package with a specific feature and the package was stored in a Git repository with another package that had a feature with the same name. This has been fixed. Number 49. Cargo fix now calls Rust C one fewer time per target, which speeds up the command a little bit. Number 50. If you use cargo new to create a new package, the new package no longer inherits the workspace package table if the package is already on the exclude list. Number 51. Cargo update -- precise was supposed to accept any form of Git reference. but it was only actually working with get SHAs. Now other ref types like branches and tags work too. Number 52. Cargo now emits a warning if you use an unknown key when you are configuring lints in Cargo.toml. For example, here's a lint section, and if you add an invalid key, you will now get a warning. Number 53. The cargo fix command automatically applies suggestions by rustc compiler lints, but this wasn't working for lints that suggested inserting a new line. Now inserting new lines is properly supported. Number 54. 10 separate pull requests updated documentation in various ways. These were all minor clarifications and tweaks, so I won't bother enumerating them. But there's a link in the description below if you want to peruse the list yourself. And finally, we have our Clippy lint updates. Number 55. The multiple crate versions lint is an existing allow by default lint that checks to see if you are using multiple versions of the same crate. It now has a new configuration variable called allowed duplicate crates that you can add to Clippy.toml to allow specific crates to be duplicated without triggering the lint, in case your life is complicated in that way. Number 56. Single call fun is an existing allow by default lint that checks for functions that are only used once. It has been fixed so it no longer ignores an allow attribute that should silence the lint. Number 57. Unit_arg is an existing warn by default lint that checks for passing a unit value as an argument to a function without using a unit literal. This lint no longer crashes when checking for const in nested bodies. Number 58. Indexing slicing is an existing allow by default lint that checks for usage of indexing or slicing. This lint no longer crashes when the array index exceeds the maximum value of a usize. This makes me very curious why exactly the person who discovered this bug was trying to pass in a ridiculously large integer literal as an index. Number 59. Suspicious open options is a new warn by default lint which checks for the suspicious use of create without an explicit truncate. This is bad because create will open an existing file if it is present and begin overriding the content, but it will not truncate the existing content if it is larger than what is being written. Number 60. Option as ref cloned is a new allow by default lint that checks for usage of as ref cloned and as mute cloned on options. This is bad because you can just clone options directly with the clone method. Number 61. The thread local initializer can be made const lint is a warn by default lint that suggests to use const in the thread local macro if possible. If you can, the implementation will be more efficient. Also, this lint might win the award for the longest lint name. If you know of a lint with a longer name, let me know in the comments below. Number 62. Stir split at newline is a new allow by default lint that checks for usages of trim followed by split with a hard-coded line ending. This is bad because hard-coding the line endings makes the code less compatible, and you can just call the lines method instead, which is both shorter and will do the right thing about line endings for you depending on which platform you are on. Number 63. Empty enum variants with brackets is a new allow by default lint that finds enum variants without fields that are declared with empty parens or brackets. These are redundant and can be omitted. Number 64. Manual is variant and is a new allow by default lint that checks for usage of map followed by unwrap or default on an option or a result. It is much more readable if you use the isSumAnd method for an option or the isOKAnd method on a result. Number 65. Pub_fields is a new allow by default lint that checks whether any field of the struct is prefixed with an underscore and also marked pub. This is bad because fields prefixed with an underscore are typically intended to be unused, but fields marked pub are typically intended to be used. So that's just confusing. Pick one or the other. Number 66. Eager transmute is a new deny by default lint that checks for integer validity checks that are followed by a transmute that is incorrectly evaluated eagerly. For example, in this code, the transmute call is executed first, and then the code that compares the now transmuted value is evaluated, which is almost certainly not what was intended. Number 67. Iter filter is sum is a new allow by default lint that checks for the use of filter option is sum and suggests replacing it with a call to flatten. Number 68. This lint is similar to the last one. Filter is okay is a new allow by default lint that checks for usage of filter result is okay and suggests replacing it with a call to flatten. Number 69. Result filter map is a new warn by default lint that checks for iterators of results using filter result is okay, map result unwrap, and suggests replacing it with a call to flatten, just like the last two lints. Who knew flatten was so versatile? Number 70. Unconditional recursion is a new warn by default lint that checks that there isn't an infinite recursion in trait implementations. This will cause a crash at runtime that will be hard to figure out, and the whole point of using Rust instead of C or C++ is that we just don't want to put up with that kind of nonsense anymore. And that's it for today's updates. The Ferris the Crab image on today's title picture is by Abby Broom, who is currently the operations manager of the Rust Foundation. This Ferris appears to have been hand-drawn in black marker on a piece of paper with hasty strokes for the main body, with a particularly jaunty top of the head that evokes the image of a Calvin and Hobbes hairdo, with special attention given to providing Ferris with adorable shiny eyes. The mouth is reminiscent of Leonardo da Vinci's Mona Lisa smile, suggesting the artist has been influenced by old Italian culture and may enjoy pizza and pasta. If you would like to add a copy of this Ferris to your collection, you can download the image at the URL provided in the description below. If you want more videos like this, like and subscribe.